So students, we're going to start with what is dissolving. And dissolving is what occurs at the surface of a solid when you mix it with some kind of solvent, and the solid kind of dissolves into the solvent. It kind of just disappears. So it's like mixing a powder into water, and the powder just disappears. And the thing that you're dissolving is called the solute, and the liquid that you're dissolving it in is called a solvent. Or the easier way to remember it is the smaller portion is the solute and the bigger portion is the solvent. And how can you increase the speed of dissolution? You can do that by stirring. So when we stir something, we kind of increase the kinetic energy, and that gets the molecules bumping into each other more often, and that's how you can increase the dissolving. But you also have to keep in mind the difference between a solid solute. So solute is what you're trying to dissolve. A solid solute and a gaseous solute. With a solid solute, when you stir, you'll increase the rate at which it dissolves. But with a gas, if you try to stir, the gas will just go into the air and spread apart. So with a gaseous solute, if you try to stir it in, it's not going to. So if you're trying to dissolve a gas in water, you do not want to be stirring. So if you look at how they put air into sodas, they increase the pressure, and that's how they do it. So if you look at the pressure variable, and if you look at a gaseous solute, they're increasing the pressure to increase the amount of gas that will be dissolved. But with a solid, pressure will have no effect. So depending on what kind of solute you're trying to dissolve, you're going to be using different techniques. So if it's a solid, you're going to be stirring, you're going to be heating it up, you're going to increase the surface area, meaning like you're going to make the solid into a nice powder, and when you really powder it up, you can dissolve it easily. And when you powder it up, you increase the amount of surface area there is for the water molecules or any other solvent to kind of interact and dissolve it. So these are the different factors that affect the dissolving rate: stirring, temperature, pressure, and surface area. And you can see the difference between a solid solute, like if you're trying to dissolve a powder, versus if you're trying to dissolve like carbon dioxide, like when you would do when you're trying to create a soda. So that's what dissolving is. And then when you look at solutions, solutions are any kind of liquid with some sort of solid or gas in it, and you can have different types of solutions. A normal solution is one that's clear, and all the particles are completely dissolved. You can see them, and the particles are less than 1 nanometer. A colloid would be a substance that can look clear in one angle, but then in another angle it's cloudy. And here there are things like jelly, shaving cream, smoke in the air. And in a colloid, you have intermediate sized particles, like the particles aren't completely dissolved. And then in suspensions, you have really large particles. And suspensions are things like salad dressing, where things actually separate out. So in a suspension, things actually will separate out and settle out, but that doesn't happen in a colloid. In colloid, things are still mixed, but it looks cloudy. But in a suspension, things actually separate out. So if you look at a snow globe or some medications, they say shake before you take it, and that's because they settle out. So those are the different kinds of solutions you can have. You can have a regular solution, which looks completely clear. Like if you dissolve salt in water, it'll look completely clear. Or you can have a colloid where it looks really murky and it looks really cloudy, but it will still won't separate out. And these are also emulsions. So if you're familiar with cooking and you're making pasta sauce, you might make an emulsion pasta sauce. And those are colloids because they won't really separate out, but they look cloudy. They don't look clear. And that's because the particles that are dissolved in it are so big. With suspensions, they will separate out. So solutions are homogeneous mixtures, and homogeneous means they look the same throughout. You cannot tell the different parts of the mixture. They look the same throughout. And you can have solid solutions, you can have liquid solutions or gaseous solutions. So don't just think you can just have liquid solutions. You can have solid solutions. Like when they mix two metals together to create a metal alloy, like steel, for example, it's two solids that are mixed together in a homogeneous manner so that you can tell the two metals apart. But two metals have to be mixed together to make steel. And brass is also that way. Two metals have to be mixed together to make brass. And both of those are solid solutions. You take solids, you melt them, and you merge them together so that you cannot tell the difference. And then you can have liquid solutions and gaseous solutions. A great example of a gaseous solution is the air we breathe. You cannot tell, oh, this is the oxygen in the air, this is the nitrogen in the air, this is the carbon dioxide in the air. It's all mixed together, and you cannot tell all the different parts. So that's why it's homogeneous, and that's a gaseous solution. So there's two parts in every solution. There's the solute, which is what is being dissolved. It's usually the smaller amount. And then you have the solvent, which is what does the dissolving, and it's usually the larger amount. And remember, the solute and the solvent can be solids, liquids, or gases. They can be either way. So how do you form a solution? Like, how can you dissolve it? So as we mentioned before, you can use agitation or stirring. So you can just shake it or stir it with a spoon, and that's how you can get the solute to dissolve. You can increase or decrease the temperature, because when you do that, you increase the kinetic energy and you have more collisions. And when you have more collisions, you can get it to dissolve that way. You can increase the surface area for dissolving. So by increasing the surface area, what we mean is you're actually making the solute smaller. But when you make it smaller, you give more room for the solvent to go sit on there and dissolve it. So when you really crush it and make it into a powder, you give more room for the water to go interact with it and kind of dissolve it. And then we have this idea of solubility. So the solubility of the substance is the amount of substance that dissolves in a given quantity of solvent at a given temperature. And so if you try to dissolve some more, it will fall out of solution, meaning it won't dissolve. It will just sit as a powder at the corner, or it will just sink down to the bottom and sit like a powder. So solubility of a substance is how much of it can you dissolve. And the more that you dissolve, the more soluble it is. The less that you can dissolve, the less soluble it is. And whenever you're looking at solubility, the variable that you want to control is the amount of solvent. So you're going to always look at maybe like 100 milliliters of water, and in 100 milliliters of water, you're going to say, keep adding salt and see how much can you dissolve at a particular temperature. And then you might increase the temperature and see how much you dissolve. As you increase the temperature, you'll be able to dissolve more. But solubility is basically how much can you dissolve at a particular temperature with a particular amount of solvent. Like, this is the amount you're given, this is the temperature, how much can you dissolve? And how do you know how much you can dissolve? Because as you keep adding more and more and dissolving it, at one point, more of it will not dissolve. It will just fall out a solution or just go to the bottom and sink instead of just mixing with the solution. So when we talk about solubility, we come up with this term called saturated and unsaturated and also supersaturated solution. So a saturated solution has the maximum amount of solute that you can dissolve. So even if you add a little bit more than that, it's going to come out a solution. So saturated solution is like, what is the maximum amount of solute? An unsaturated solution has less than this maximum amount. So basically for unsaturated, you just add less than the maximum amount. And then you have a supersaturated solution. It's a solution that theoretically holds more than the maximum amount. And that, like, you should have a question in your mind. How can you hold more than the maximum amount? So the way we do that is we create a saturated solution, and then we raise the temperature of it and add more solution and dissolve. So as you raise the temperature, you're able to dissolve some more. So you raise the temperature and you dissolve some more, and then you cool the solution down again. And when you do that, sometimes you still get the solute to stay dissolved even though you've cooled it down. And when you've cooled it down, what you've done is you've created a supersaturated solution, because you artificially were able to dissolve more by raising the temperature. So let me go through that again. You take a solute that you're trying to dissolve in a solvent. Solute is the smaller portion, solvent is the bigger. and you put it in a solvent and you dissolve it, right? And you put in the maximum amount. If you put any more, it's coming out a solution. Then what you do is you raise the temperature and you keep adding more and dissolving it. Okay, now at a higher temperature, you've got a saturated solution. Now you cool down the temperature, and so now if you just start out brand new and try to dissolve at that temperature, you won't be able to add as much as you've added in this supersaturated solution. So supersaturated solution is to like unnaturally add more solute by first raising the temperature and then dissolving more and then cooling it down. And then key things to remember: in a solid solute, as the temperature is raised, solubility increases. But in a gaseous solute, as you raise temperature, the solubility actually decreases. So the solubility of gases is actually greater in cold water than in hot water. That's why if you heat up your soda or leave your soda in the sun for a long time, all the gas in there will disappear. Because when you leave it in the sun or when you leave it out, what happens is the kinetic energy increases because the temperature increases. So they bump into each other more and the gases find ways to escape the solution. So if you are trying to dissolve a gaseous solute, you want to decrease the temperature. If you're trying to dissolve a solid solute, you want to increase the temperature. Okay. When two liquids are said to be miscible, if they are able to dissolve in each other. If the two liquids do not dissolve in each other, then they're called immiscible. Like for example, oil and water are immiscible because they will not dissolve in each other. But if you have like a soap solution and you try to dissolve in water, that will dissolve. So that is miscible. Miscible means two liquids that will dissolve in each other. Immiscible is like oil and water. They will not dissolve in each other. They're insoluble. And then when you talk about solubility, the key thing is to remember is like dissolves like. So polar molecules will dissolve in other polar molecules and non-polar molecules will dissolve in other non-polar molecules. And ionic or charged molecules are similar to polar, so those will also dissolve in polar molecules. And covalent molecules are generally non-polar, and so they will dissolve in non-polar. So remember when we talked about bonding, ionic bonding and covalent bonding. With ionic bonding, we had those charges, right? So that's what we're talking about here. Ionic compounds will dissolve in polar solvents. Covalent compounds will dissolve in non-polar solvents. And so like dissolves like. Polar will definitely dissolve in polar, but ionic will also dissolve in polar. And then covalent will dissolve in non-polar. So water is a polar molecule and therefore water is a universal solvent. So also I wanted to point out, students, in the beginning there were some slides on what is the structure of water and the special properties of water. I've given you a do now to do based on the properties of water. So I'm not going to spend more time here on the properties of water, but definitely read that article and complete the do now. Okay, and you should have done that before you watch this lecture. Okay, let's keep going. So water is a polar molecule. So any ionic compounds and any polar compounds will dissolve in water. And that's why water is actually called a universal solvent, because so many things dissolve in water. Okay, and hint, hint, that's a question in your do now. So water is a universal solvent. It can dissolve both polar molecules and ionic or charged molecules. And then the last thing we're going to be talking about in this lecture is what is an electrolyte versus what is a non-electrolyte. So if you dissolve something in water and then you connect a battery to it and you connect a light bulb to it and the light bulb turns on, meaning the solution can conduct electricity, then that is called an electrolyte. So for example, if you dissolve salt or NaCl in water, the Na and the Cl will separate. And when they separate, Na has a positive charge and Cl has a minus charge. So that solution is an electrolyte because when you connect a light bulb to it, it will produce electricity and the light bulb will turn on. So you just need to put two electrodes and put a light bulb on top of that salt solution and the light bulb will turn on. Now, a non-electrolyte solution is a solution that you dissolve in water and it does not conduct electricity, and that's sugar, for example. Because when sugar is dissolved in water, it will not separate into ions. So it will just dissolve and it will stay together. The sugar molecules will stay together. So therefore, that if you try to put a light bulb, if you connect electrodes and put a light bulb there, the light bulb will not turn on. And so that is a non-electrolyte. So electrolytes are solutions that can conduct electricity. Non-electrolytes are solutions that cannot conduct electricity. And electrolytes are usually, if you take an ionic compound and dissolve it in water, you get an electrolyte. And those can also be acids and bases, because acids and bases will also separate in water. And we'll talk about more of that in our next unit. But basically, remember, any ionic compound or acids and bases, when you dissolve it in water, they separate out into their ions, which have a positive and negative charge, and so that is going to conduct electricity. Okay, that's all on water solutions.